Okay, we will do some more problems on the multiple angles. Okay, multiple angle means 2a, a by 2 theta, theta by 2, all those angles, 3 theta, what the angles we saw in the earlier class. Okay, so this problem we can solve. Show that cos theta plus I sin theta, okay, whole cube is equal to cos 3 theta plus I sin 3 theta, where I square equal to -1. Okay, so this is something we will see it in the later class what this is. Okay, because this is something what we call as a complex number. Okay, so before I can give you just a brief introduction of it. See, something like, suppose I give you an equation. What is that equation you have? Suppose if you have an equation like x square minus 4x plus 5 equal to 0. We can solve for it. Okay, so how do we solve it? So if we have ax square plus bx plus c is equal to 0, the solution is x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Correct? So here what it will be? X will be equal to minus b is 4 plus or minus root of b square. What is b square? 16. B square minus 4 into 1 into 5, that is 20. Correct? Divided by 2. Okay, so now, so if you remember, if you remember earlier in 9th standard, if you have a linear equation, it will intersect at one point, right? Only one solution. If it's a quadratic equation, so we will have intersection at 2 points. Correct? If it is a cubic equation, then becomes 3 points or something like that. We saw it in the 9th standard, sorry, 10th standard. Correct? So now this is so this equation should also have 2 points intersection at the x-axis. Correct? If you plot it, you should have intersection at the x-axis. Correct? Because the quadratic equation. So let us see what this will be. You take x is equal to 4 plus minus, this is what? Minus 4 by 2. Can you do minus 4? No. So what we can do is, so this is what we call, this is an imaginary solution. If you remember, 10th standard what we found, this solution is an imaginary solution. What is the imaginary solution you get? If b square minus 4ac, if it is less than 0, then we say there are no real roots. You remember? So it has no real roots. So but this quadratic equation is a valid equation. Correct? It is a correct quadratic equation. So it has a solution. But the solution is not a real root. That means it's having roots somewhere else. Other than the real numbers what we know. Correct? So what we can write like this is equal to, I can write 4 plus or minus this one, I am going to write it as minus 1 into 4 by 2. Okay, so then I can write it as 4 plus or minus, so the root of minus 1 into root of 4 will be equal to 2. Correct? Divided by 2, so this is going to be 2 plus or minus root of minus 1. Correct? So, and this minus 1 is a minus root of 1. If you remember in a 9th standard, we have a number line, right? We draw a number line and we define the real numbers and all. Is there anywhere else you can place minus root of 1 there? No, minus root of 1 doesn't remain in the real number domain at all. Correct? The number line when you draw. So there is nothing like minus root of 1 I can do. Okay, so the number descriptions what we have. So that I will explain more about in the complex when you go to complex numbers. Okay. So in the way of representing numbers, we are missing one important number, that is the minus root of 1. Okay, so we have to add up one more term. Okay, so what they call is, they call this as an imaginary number. So what they write is I equal to minus root of 1. Okay, then I can write it as 2 plus or minus I. Okay, so this combination, so what happened? So you suppose if there is some other number is there, so this is 1i. Okay, so then what happens? So this number usually represent as z. So this number is called as your complex number. Okay, a complex, so this is what you call as the real part of the complex number. This is a real number, correct? And this is what you call as the imaginary part of the complex number. Okay, this is real, and this is imaginary. Okay, so this is all. This is a real in when your imaginary parts become 0. Okay, then your complex numbers will actually take out the real number. All solutions will be real. Okay, till then in your 10th standard, what you've seen is you considered only those numbers for which your imaginary part is 0. Okay, when the imaginary part is 0, your whole number is real. But in reality, you will have the numbers where the imaginary part is non-zero. So in reality, what the number we are going to deal is always the complex numbers. So under a specific criteria condition, that complex number will become just a real number. Okay, so this we will see it in the later on class. Okay, why this complex numbers comes and all. And it's a very interesting tool to solve also. Okay, many times you're expressing the problems as a complex number, your solutions can be interesting. So this is the introduction to complex number. Whereas they given a problem in the complex number. This I is called as the name is iota. So here the sine angles and the cos of the angles are given in terms of the complex number. So we will have to solve it. So what we saw, if you remember, I is equal to square root of minus 1. Correct? So what will be I square? Oh, it will be 1? It will be minus 1, na? Minus 1 into minus 1 whole square, so this will be minus 1, I square. See, that's what, I square equal to minus 1, that's why I is equal to square root of minus 1. Okay, so I cube will be equal to what? I cube will be equal to I square into I, correct? So I square is what? Minus 1 into I is same I only, minus 1. So this is equal to, so I cube equal to, so I cube will be equal to minus I, correct? So I cube equal to minus I. Minus I power 4 will be, you can always do that. I power 4 equal to what? I square into I square, that is equal to minus 1 into minus 1 equal to 1. So you can keep on doing that, powers of it. Okay, so this is a complex number. So what happened? So if you see, these are all complex, correct? When you take a square of the imaginary part, it can turn to real. Okay, so these are the something here. So let us now start up with this problem. This problem is simple. So we have cos theta plus I sin theta whole cube, right? Let me just expand the cube formula. What is the formula for a plus b whole cube? A cube plus 3a square b plus 3ab square plus b cube, correct? So this will be what? Cos cube theta plus 3i, correct? A square, so cos square theta sin theta plus 3i into cos theta sin square theta plus I cube, correct? I cube sin cube theta. I cube sin cube theta. Now what is I cube? I cube equal to minus I. So this I can write it as minus I, correct? Minus I. Okay, see, remember we cannot add any, this is a real component, there is no I, correct? So you cannot simply add that real component to the imaginary component. Real component goes completely different calculations. Imaginary will also go as imaginary. Only if somehow if you are able to convert the imaginary into real, when it becomes I square, the imaginary will become real. Okay, then only you can add up the real component. Fine. So this is, so what we have, cos cube theta plus 3i. So let us expand this because we wanted to see, remember, here taken cos 3 theta, sin 3 theta. If you remember the formula for cos 3 theta, sin theta, what is the formula? Cos 3 theta will be equal to, you remember today? So cos 3 theta is 4 cos cube theta minus 3 cos theta. If you don't remember, you can solve it also. It doesn't take much of time. Sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. Sin cube theta. Okay, so you can see. See now, if I somehow able to express this in terms of sin square theta, then that will combine with this and become sin cube theta. And here also, if I able to express this as a cos square theta, that combines with cos and becomes cos cube theta, you can get this formula. And then you can get this cos 3 theta. That's the idea. So what happens is 3i cos square will be, I am going to write as 1 minus sin square theta sin theta plus 3i cos theta 1 minus cos square theta minus I sin cube theta. Correct? So let us open it. Cos cube theta plus, what are we missing? Some real component? Oops, yeah, we missed it, nah? Oh, you also didn't notice. See, what is that? A plus B whole cube equal to a cube plus 3a square b plus 3ab square plus b cube. Okay, so you should remind me when I am making a mistake. See what happened, what we did is, okay, this is cos square theta, okay, this is sin square theta, na? It is I square sin square theta, correct, na? So it will not be I. So when it I square, what has happened? I square is nothing but minus 1. So this will become minus 3, correct? So this is also I square here. So I square is minus 3, so this will become minus 3 cos theta. Okay, usually that's why I was just wondering why you are not getting the real component. Okay, now let me open this. So this is open. 3i sin theta. Okay?
Minus.
It will be minus 3i sin cube theta. Be careful. If I do a mistake, find it. Okay? So this will be minus 3 cos theta. Then
Minus
plus, no, minus plus, na? 3 cos cube theta minus I into sin cube theta. So now what happened? As I told you, you cannot add up the real part and the imaginary part. You have to keep them separate. Let us combine all the real parts separately and all the imaginary parts separately. So what are the real parts? Cos cube theta. Is there any other real part is there? Yeah, these two are there. Correct? Correct? Yeah. So we have minus 3 cos theta plus 3 cos cube theta. And let us combine the imaginary part now. That is plus 3i sin theta minus 3i sin cube theta minus I sin cube theta. Correct? So let me take the I commonly outside. So here this will be, so what is going to be cos cube theta minus 3 cos theta and 3 cos cube theta. These both will become 4 cos cube theta. Correct?
Minus 3 cos.
Minus 3 cos theta. Good. Minus 3 cos theta. Let me take the I commonly outside. So plus I. If I take I commonly outside, what I am going to get? 3 sin theta minus 3 sin cube theta minus sin cube theta. Correct? So this will become minus 4 sin cube theta. Correct? So this is going to be minus 4 sin cube theta. So now let us use the formula. You can see 4 cos cube theta minus 3 cos theta is nothing but cos 3 theta. Cos 3 theta. And then 3 sin theta minus 4 sin cube equal to 3 sin theta plus I into sin 3, not sin 3 theta. That is equal to RHS and hence proved. Okay. So let us do this problem. Find sine x by 2, comma, cos x by 2, comma, tan x by 2 if tan is equal to minus 4 by 3. There is a typo in your book, I checked. Tan x equal to minus 4 by 3. In the book it is written 4 by 3, but it is typo. Why I can say is, we can very clearly say, because x lies in second quadrant. So from here itself, if it is second quadrant, tan has to be negative. Correct? So that's what they have. See, there are many ways you can do this problem. It is not very tough. Okay, so what we can say, there is one simple way to look at this problem is, let us suppose if I have a quadrant. This is the first, second, third, and fourth. Okay. So what they say, your x lies in the second quadrant. Correct? So this is second quadrant. So where half of x will be? Will be? Suppose if this is the one, half of 180 is 90. Correct? So anything less than that half will fall here. Isn't it? So therefore, if x lies in second quadrant, x by 2 will lie in first quadrant always, and that gives us a clue. So since x lies in second quadrant, x by 2 will be in first quadrant. Okay. First quadrant. This is the clue we got. Okay, so now then we have to use is the formula. So what we given, tan x is equal to minus 4 by 3. So we know the formula, na? So tan x, so we know that what's the formula? Tan 2 theta equal to twice tan theta into 1 minus tan square theta. Correct? So if we replace theta as x, so then tan x will be 2 tan x by 2, correct? 1 minus tan square x by 2, correct? So I can just write it. So tan of x is equal to what? That is equal to twice tan x by 2 divided by 1 minus tan square x by 2. So this is equal to minus 4 by 3. So let us write tan x by 2, or let us write y equal to tan x by 2. So then this equation becomes 2y divided by 1 minus y square equal to minus 4 by 3. We got a quadratic equation, correct? So what this will be, you tell me? So this is going to be 6y equal to, so minus 4y square becomes 4y square minus 4. Okay? Or 4y square minus 6y minus 4 equal to 0. So if I can divide by 2 everywhere, we can reduce it further. So if I divide it by whole thing dividing by 2, so what it will become? 2y square minus 3y minus 2 equal to 0. So what will be y? Y equal to, say, minus b plus or minus 4. Minus b is 3 plus or minus b square is 4. B square is 9. B square is 9.
Plus 4 into 2 into 2.
So that is 16, correct? 16. Divided by 4. Okay, so this is what? 5. It was 25. So this will be 3 plus or minus 5 by 4. Okay, so what this will be? So when it is plus, it is going to be 8 by 4.
2.
That will be 2. Or if
2
it is
by 4.
minus,
2 by 4.
minus 2 by 4. Correct?
Okay, correct.
Huh? So minus 2, minus 2 by 4, that is equal to minus 1 by 2. Am I right? So, but now we said, what is your, so y equal to, so when I put, so therefore, tan x by 2 is equal to 2 or minus half, correct? Now x by 2 is in first quadrant. Everything has to be positive. Therefore, since x by 2 is in first quadrant, tan x by 2 will be equal to 2. Correct? So we got the answer for tan x by 2. So therefore, let me write down here itself, we don't have a space. Okay? Therefore, tan x by 2 equal to 2. So now we have to go for other formulas and all. Correct? That should not be a. How will we do that? You tell me.
We can find out with the identities.
Yeah, okay, let us use identities, you're right. So what we are going to do, okay, we can use tan is there, na? So we want to find, if I find, because I know tan and secant will have a identity, 1 by secant will give me cos. So this will be secant square x by 2 minus tan square x by 2 equal to 1. Okay, so tan square x by 2 is nothing but 4, am I right? Alright, so this is equal to 4. So therefore secant square is equal to 4. If I take it here, this makes
5
plus 4. So that's plus 4 and that is equal to 5. So secant square x is equal to 5. Therefore secant x by 2 is equal to plus or minus root of 5. Again x by 2 is in first quadrant. Okay. So therefore since x by 2 in first quadrant, we have secant x by 2 equal to root of 5. So we got that answer also. So we have secant, secant, therefore we have cos, therefore cos x by 2 equal to 1 by root of 5. So cos x by 2 equal to 1 by root of 5. Okay, and then we are going for the last one, right? That is sin x by 2. So yeah, okay, how do you use? Okay, we have the cos formula. Of course, we can use it easily. Sin square x by 2 equal to 1 minus cos square x by 2. Cos square x by 2. So cos square equal to 1 by 5. Correct? So this is going to be 1 by 5. So this will be what? 4 by 5. 4 by 5. Again, sin x by 2 will be plus or minus root of 4 by 5. So now it's the first quadrant, it has to be only positive, so we will have only the positive solution. So we got the sin of x by 2 also equal to
2 by root 5.
2 by root 5. Correct? So we got the other three numbers. So we will do this problem also. Find the value of, this is this is interesting, tan pi by 8. Correct? You remember, this is not a standard angle, right? So now we have to find the tan pi by 8. So now we can always know. So now if you see tan pi by 8 is, can I write it the combination of the standard angles? Because we know tan pi by 8 is, if I write 2 times pi by 8, that is equal to pi by 4. Am I right? That itself give an idea. So it is a half of, half of pi by 4 angle is pi by 8. So I know the formula for tan pi by 4. Correct? What is tan pi by 4? That is 45 degree, na?
Tan 45 equal to 1.
1. Yeah, is equal to 1. So let us have a formula. So now what I can say is, how will we use this formula? So we will use this formula, tan 2 theta. So what we will use tan 2 theta formula? What is the tan 2 theta? Tan 2 theta is equal to, tell me, 2 tan theta divided by 1 minus tan square theta. Okay. Suppose if you let us write theta is equal to pi by 8. So then what it becomes? Tan 2 theta, na? This is pi by 4 equal to 2 times tan pi by 8 divided by 1 minus tan square pi by 8. So you can easily find out that. So what happens? So we have what we'll have is tan pi by 4 equal to 2 times tan pi by 8 divided by 1 minus tan square pi by, oops, sorry, this is 8, right? Tan square pi by 8. So now tan pi by 4 is 1. So this is going to be equal to 1. So we are having 2 tan pi by 8 is equal to 1 minus tan square pi by 8. The usual formula. Let us write x is equal to tan pi by 8. Therefore this says 2x equal to 1 minus x square. Correct? So or x square plus 2x minus 1 equal to 0. So x is equal to minus b, that is minus 2, plus or minus b square, that is 4 minus 4ac. So this is plus, so 4 plus 4 divided by 2. Correct? So what it will be? So this will be minus 2. So this will be what? Plus or minus root of 8, right? So 8 will be what? 2 root of 2. Correct? So square root of 8 is equal to 2 times root of 2 divided by 2. This is equal to, when I divide by 2, so minus 1 plus or minus root of 2. Okay? So, okay. So now, so what is that? That is tan pi by 8. Therefore, we have tan pi by 8. This is tan pi by 8, right? So tan pi by 8 formula will follow in the first quadrant, because tan pi by 4 is 45 degree. Pi by 8 is half of 45 degree. Correct? So it falls in the first quadrant. In first quadrant, everything has to be positive. So if I take this as negative, then it's going to be negative. Okay, if it's positive,
it should be plus.
why? Do you know what the value of root of 2? Typically 1.414. Okay, so naturally it will be greater. So positive. Okay, so therefore tan pi by, so what you write, since pi by 8 falls in first quadrant, tan pi by 8 equal to minus 1 plus root of 2. That's the formula. Okay.